Grand Canyon were different too. You know, we look out at the canyon expecting to see red and we'd see green, and the green was not the same plants that we see growing there today. As the temperatures changed at Grand Canyon, we found actually a number of different creatures or different plants moving up and down the walls of the canyon in response to temperature change. At the height of the Ice Age, when the temperatures were the coolest and the rainfall was the highest, we would have found forests very similar to the ones that are growing along the North Rim, growing all the way down in the canyon to the brink of the red wall limestone. So Douglas fir, white fir, and limber pine growing well down into the canyon at the height of the last Ice Age. Down near the Colorado River, we would have found juniper woodlands. We would have seen some, looking more closely though, we would have seen some differences from what we see today too. You notice that I say down here near the river, we would have seen juniper woodlands. Today, we can hardly say the word juniper without saying pinyon. We always say pinyon juniper. It's a pinyon juniper woodland. I'm sure that newcomers to Arizona think that there's a plant called pinyon juniper. But yet, during the Pleistocene, during the Ice Age, we had juniper growing here, not pinyon. Pinyon were restricted to a range further south. The other thing that was missing at that time was ponderosa pine, and instead our dominant pine species was limber pine, a type of pine that no longer grows here. So when the ice sheets began to melt, the limber pine disappears from our fossil records in the Grand Canyon. Limber pine vanishes about 12,000 years ago. Today we have to go up into central Utah to find it. Now it's not a case that the ponderosa pine somehow displaced the limber pine. The ponderosas didn't show up until about 9,000 years ago. And actually the ponderosa arrived right about the same time that the summer monsoon season begins to form after the ice sheets had melted. So we had habitat changes. It wasn't simply the differences in temperature and precipitation, cooler and wetter. It was also the seasonality, the absence of a summer monsoon that helped to shape the way things were during the Pleistocene, during the Ice Age at Grand Canyon. So knowing that the climate has changed so many times in the past here at Grand Canyon, what can we say about the future? Well, what I'm going to do is I'm going to mostly draw my projections, just so you know, from the Intergovernmental Panel on Climate Change, the IPCC. It's their 2007 report. So this is, we had 152 climatologists from 30 countries, more than 600 reviewers, and it was approved line by 13 governments, including the United States. So, I also found some great material on the AM Talk Radio website, but I didn't have time to include it in tonight's presentation. Why do we call it climate change? Whatever happened to good old global warming? Well, part of the reason that we actually use the term climate change is that warming isn't the only story. Air and ocean temperatures are going up. We're also talking about the melting of the snow and ice on mountains, on the ice caps, talking about changes in sea level. We're also talking about changes in precipitation patterns. So it's not just the temperature that's changing, it's the entire climatic system. And some of the things that we're seeing going on in the world today do very much seem to be the result of human activities, including those things that I mentioned before. Now, let's see. One of the things, the first bullet on this one just talks to you a little bit about the expected changes. But I think the real interesting point is that according to the models and according to the climatologists, even if we stabilize greenhouse gas emissions today, boom, we're going to just not increase the carbon dioxide level any higher than it is now, just as much methane, not a molecule more in the atmosphere. It's still going to take a long time for the climate system to settle back down again because of the changes in the gas concentrations. And in fact, there are some aspects of our climatic system, including ocean circulation, that will take centuries to stabilize. once we stop the growth in carbon dioxide levels. So now, if you read the IPCC report that I gleaned this information out of, you'll find that there are a lot of different scenarios. If we aggressively control carbon, if we go on to business as usual, if we do this, if we do that, this, that, and the other. So lots of different scenarios, lots of different ranges in temperature increases and precipitation changes that we can talk about. And so what I'm going to do is not so much talk about the different scenarios, but talk about the implications of the process in general. So first of all, we'll take a look at our greenhouse gases, those same greenhouse gases that we started talking about earlier that keep the Earth from freezing over, that make us a habitable planet. And we can see that from the year 0, so now we're talking about the very recent geologic past, the year 0 up to the year 2000, we have our carbon dioxide levels. Methane is kind of like doing the same thing. And not to be left out, our other greenhouse gas, our most powerful greenhouse gas, the nitrous oxide, they all take off too. So we do see this tremendous increase that starts about 1750, right when we discover burning coal. What a coincidence. The one thing that I should point out is that this blue line, methane, is actually at higher concentrations than it really should be, according to different climate models. And there are some folks who think that actually methane was our first climate crisis due to agriculture. Rice paddies and domestic ungulates are great methane production facilities. I won't go into exactly how the ungulates produce the methane and what it smells like when it's produced and all that kind of stuff, but there's a lot of methane that comes from that source. And so some people actually think that had it not been for early agricultural practices, ice sheets might already be forming in northern Canada. Other climatologists beg to differ. That's what keeps them employed and keeps the grant money coming in. So, taking a look, what are the causes of climate change that we're anticipating, that we've seen since 1750 and we're anticipating in the future? Part of it is a change in solar radiation. The sun is getting hotter, but it's not very much of a change. There are some things, these things up here are human activities, and some of our human activities are actually causing the temperature to get colder, these blue bars. So for example, when we convert forests to croplands, it makes the planet cooler by reflecting more light. When we put up air pollution, some of that air pollution reflects sunlight back into space or helps to create clouds that reflect sunlight back into space. And so that cools the planet off. There are other things that we do that warm the planet up, like produce carbon dioxide, more greenhouse gases. Here's some more of our, here's methane as a carbon dioxide, or methane as a carbon dioxide. Methane is greenhouse gas, and some of the others. They're warming up the planet. Ozone helps to warm up the planet. If it's in the lower atmosphere, cool the planet if it's in the upper atmosphere. The sum of all of these different effects, though, is what we see down here in the bottom. A net warming of the Earth. So what's that going to mean for us here at Grand Canyon? Grand Canyon in the crosshairs, right there. This is annual temperatures, winter temperatures, and summer temperatures. So on the Colorado Plateau in general, we're expecting over the next century temperatures to increase somewhere between 3 and 11 degrees Fahrenheit. And I might point out, 3 to 11 degrees, it doesn't sound like very much. I mean, I'm hoping that it'll be more than 11 degrees warmer this summer outside than it is right now. I can put up with an 11 degree temperature increase. But when we start talking about 11 degrees on the average, we're talking about some very fundamental differences. And in fact, that is the maximum here, 11 degrees Fahrenheit, 6 degrees Celsius. That's how much colder it was at the height of the last glaciation. So 6 degrees separates us from the last glacier, the last advance of the glaciers. What will 6 degrees in the other direction portend for us? Well, one of the things that we know is going to happen is that there's going to be an increase in water stress. Even if precipitation stays the same with higher temperatures,